At 9:07 on the morning of the 4th of September 1943, Edith Carolyn Marsh drew a single pencil line across the underside of a wing panel and put the pencil down on the inspection bench. The panel in front of her was from a Supermarine Spitfire Mark VIII, serial number JF491, freshly delivered to the Quality Inspection Bay at Castle Bromwich Aircraft Factory, Birmingham. The panel was clean, newly riveted, signed off by 2 shift supervisors and a factory floor inspector. It had, by every formal measure in the RAF Directorate's approval chain, already passed. The delivery paperwork was in order. The measurements were within tolerance. The rivet spacing had been checked against the manufacturer's specification card. 3 men with clipboards had looked at it and seen nothing wrong. Edith was 34 years old, 5 feet 2, and had been doing this job for 14 months. She had no engineering degree. She had trained as a technical draftswoman before the war, and before that, she had spent 6 years as a school teacher in Coventry, teaching geometry to 12-year-olds who mostly did not want to learn it. What she had, in place of credentials, was an eye for line, a specific, practiced, almost physical sensitivity to the relationship between a drawn edge and a flat surface that she had developed over 2 decades of working with pencil and ruler, and could not fully explain to anyone who asked. The pencil line ran along the panel's camber seam, following the curve precisely. Or, rather, it did not follow it precisely. 3 centimeters past the second rivet row, the line departed from the surface by a fraction so small it was not visible to the naked eye at inspection distance. Edith saw it because she was looking for it, and she was looking for it because she had learned over 14 months that this particular departure, at this particular point on this particular panel geometry, was where metal fatigue under load stress first began. She put a red chalk mark beside the rivet row, wrote 2 numbers on the inspection tag, and set the panel aside. By the end of that morning, she had rejected 7 panels from the same production batch. The floor supervisor, a man named Harold Grout, 56, former machine tool engineer, entirely reasonable in most circumstances, told her she was holding up the line. She told him she was aware of that. He told her the panels had already been checked. She told him she knew that too. What nobody in that inspection bay yet understood was that Edith Marsh's pencil line was about to expose a structural failure pattern that had already put aircraft into the ground. Edith had grown up in Leamington Spa, the eldest of 4 children born to a technical illustrator father who worked for a firm producing engineering manuals. Her father, George Marsh, had spent his working life drawing things with absolute precision, valve assemblies, gear mechanisms, brake systems, and he had believed, with the quiet certainty of a craftsman, that the most important skill a person could develop was the ability to see whether a line was true. He had taught Edith with tracing paper and a set of drawing instruments bought secondhand from a cartographer's estate sale. They would sit at the kitchen table on winter evenings and trace engineering diagrams, and he would hold her work up against the original and find the places where her line deviated. Not by much, never by much, but by enough. He never criticized the deviation. He simply pointed to it and said, "There, what caused that?" And Edith would look and think and eventually identify whether she had applied uneven pressure or lost her reference point or let the set square drift by half a degree. By the time she was 15, she could identify a half-millimeter departure from a design curve at 30 centimeters of viewing distance. By the time she was 22 and working as a draftswoman at a Coventry engineering firm, she had developed the habit, automatic, almost unconscious, of running her eye along any manufactured surface to check it against its implied geometry. She did it with window frames. She did it with tabletops. She did it with the ruled edges of printed forms. It was not obsessive. It was simply how she saw. A line was either true or it was not. And if it was not, she wanted to know why. When the war came and Castle Bromwich converted to aircraft production, Edith had applied for a draftswoman post and been assigned instead to quality inspection. The supervisor who placed her there had done so because draftswomen were in short supply and inspectors were needed urgently. He had not understood what he was actually putting on that inspection bench. Neither, at first, had Edith. Between January and August 1943, 6 Spitfires from the Castle Bromwich production line had experienced structural panel failures during operational service. Not catastrophic failures, nothing that brought an aircraft down immediately, but stress fractures and separation events in wing and fuselage panel seams that required emergency repair, grounded aircraft, and in 2 documented cases caused pilots to abort combat engagements over the channel. The RAF's technical investigation had identified the failures as falling within acceptable manufacturing variants. This was not negligence. The variance figures were based on pre-war metallurgical standards that had been established for peacetime production rates. What the standards had not anticipated was that wartime production pressure, combined with an increasingly inexperienced factory workforce replacing the skilled men now in uniform, was systematically producing panels that were technically within tolerance, but structurally compromised in ways the tolerance figures were not designed to detect. Flight Lieutenant Daniel Ashworth, the RAF liaison officer assigned to Castle Bromwich, had filed 3 separate technical reports on the failure pattern between March and August. Each report had been reviewed, acknowledged, and filed. The recommended response in all 3 cases was tighter supervisor oversight and re-emphasis of existing inspection protocols. Sergeant Technician William Oakes, based at RAF Hornchurch, had written in his personal log, later preserved in the Imperial War Museum's collections, that the 6th aircraft to ground with a panel separation fault had been his responsibility to repair. He wrote that the fault line had been in exactly the same location as the 2 previous aircraft he had worked on, and that he had mentioned this to his commanding officer, who had told him to note it in the maintenance record. The maintenance record had been noted. Nothing had changed. Pilot Officer James Harridge, 23 years old, from Swindon, had been flying the 5th aircraft when the port wing panel had developed a stress fracture at 22,000 feet over the Pas de Calais. He had brought the aircraft home. He had filed his report. In the report, he used the phrase, "She felt wrong from the moment I pushed her past 400. The report was filed. He had died 3 weeks later, unrelated, in a separate engagement. Edith Marsh did not know about any of these cases. She was working in a factory, not a briefing room. What she knew was what she could see on the inspection bench in front of her, and what she could see, by September 1943, was a pattern. She had presented her findings to Harold Grout in the 2nd week of August, 3 weeks before the morning with the pencil line. She had brought her inspection logs, 14 months of hand-recorded measurements, panel reference numbers, deviation notations, and she had laid them on his desk and walked him through the pattern. The deviation she was measuring was in the panel camber seam geometry, at the point where the wing skin panel met the structural rib beneath. In correctly manufactured panels, this seam described a specific curve. In the panels she was flagging, the curve departed from specification by between 0.5 millimeter and 1.2 millimeters at a point approximately 8 to 12 centimeters from the 2nd rivet row, to the formal inspection protocol, which measured rivet spacing, overall panel dimension, and surface finish. This departure was invisible. The measurement it required was not on any inspection form. Grout had listened carefully. He was a fair man. Then he had told her that the measurement she was proposing to add to the inspection protocol was not part of the approved RAF specification, that adding unapproved measurements to signed inspection records was a procedural breach, and that if she had concerns about panel structural integrity, she should raise them through the formal technical query process, which had a 4 to 6 week review timeline. "I've raised 7 panels this week," she said. "And I've approved them," he said. "They're within spec. They're within the spec that doesn't measure what I'm measuring." "Then submit a technical query." She submitted a technical query. Flight Lieutenant Ashworth reviewed it and sent back a response noting that the proposed measurement was non-standard and that any modification to inspection protocol required sign-off from the Air Ministry Directorate of Technical Development. The timeline for that process was, he wrote, approximately 3 months. Edith went back to her inspection bench and kept drawing pencil lines. She developed the method over 4 weeks, working through her lunch breaks in the first hour after her shift ended. At the inspection bench, with a set of panel reference drawings she had requested from the drafting office, on the grounds that she needed them for routine measurement checks. The pencil itself was a 4H technical drawing pencil, sharpened to a consistent point with a fine sandpaper block the way her father had taught her. The hardness was critical. A softer pencil would leave a line wide enough to obscure the deviation she was measuring. The 4H line was fine enough to show it. She held the pencil at a consistent 17-degree angle to the panel surface, resting its barrel lightly against the curve of the camber seam, and drew it along in a single continuous motion without lifting. The resulting line followed the seam geometry exactly, and where the seam geometry departed from the design specification, the pencil line showed it because the pencil, following the actual surface, diverged visibly from the reference line she drew beside it using the panel's own rivet row as a straight edge. The technique required no measuring instrument. It required no additional equipment of any kind. It required a 4H pencil, the inspection bench, and the ability to see what the line was doing. She established that a departure of more than 0.5 millimeter from the reference at the critical point, 8 to 12 centimeters from rivet row 2, correlated with every panel she had already flagged on other grounds. She then ran her pencil line method retrospectively against a sample of approved panels and found 19 that she would have rejected. She documented all of this in a 14-page handwritten report with panel reference numbers, deviation measurements, and a diagram showing the critical geometry zone drawn in the precise style her father had taught her. Clean, annotated, unambiguous. She gave the report to Harold Grout on a Tuesday morning. He read it that afternoon. He told her not unkindly that he could not act on a measurement method that had not been formally approved, and that the report, while thorough, was not an official document. She asked him what an official document would look like. He described the required format. She went home and rewrote the entire thing in the required format. He submitted it. 3 weeks later, the morning with the pencil line. On the 4th of September, Harold Grout arrived at her inspection bench at 10:30 with Flight Lieutenant Ashworth and a man from the Air Ministry whom Edith was not introduced to by name, but who carried a leather briefcase and wore civilian clothes and a look of careful neutrality. Grout had, to his considerable credit, done something unexpected. He had pulled 12 panels from the previous week's approved production batch and arranged for them to be brought back to the inspection bay for a demonstration. Edith applied her pencil line method to each panel in sequence. She worked in silence, methodically, calling out her findings as she went. Panel reference, deviation present or absent. Deviation magnitude where present. 7 of the 12 panels showed deviation at the critical zone. She set them in a separate row. Ashworth watched without speaking. The man from the Air Ministry asked her, after the 5th panel, what the pencil was doing that a standard measurement instrument would not. She told him that the pencil was following the actual surface geometry, and that the human eye, trained to compare one continuous line against another, could detect a half-millimeter departure more reliably and more quickly than any instrument measurement taken at discrete points, because discrete point measurement missed what happened between the points. She told him she could do 12 panels in 22 minutes using this method, against 45 minutes for the full standard protocol. He asked if it could be taught. She said she thought so, yes. Ashworth asked what would happen to an aircraft flying on a panel showing the deviation she was measuring. She said she was not a structural engineer and couldn't answer that precisely. What she could tell him was that every panel she had previously flagged on other grounds, panels she had already had good reason to reject, had shown the deviation, and every panel she had approved had not. The 7 panels from that morning were sent for independent metallurgical analysis. The analysis, completed 11 days later, found stress concentration indicators in the rivet zone of 6 of the 7, in standard operational conditions at high speed and high altitude. 4 of the 6 were assessed as likely to develop fatigue fractures within 200 flying hours. Ashworth came back to the factory on the 16th of September with 2 men from the Directorate of Technical Development. They asked Edith to walk them through the method again, this time against a fresh batch of panels that had been pulled from that morning's production run without her knowledge. A blind test. She applied the pencil line to 22 panels. She flagged 9. The DTD men ran full standard protocol measurements on all 22. 3 of the 9 she had flagged showed measurable out-of-tolerance deviations on standard instruments. The other 6 were within formal tolerance, but, when subjected to the same metallurgical analysis used on the earlier batch, showed stress indicators consistent with premature fatigue. One of the DTD men, a structural engineer named Morrison, asked to see her 14-page report. He read it at the inspection bench while she stood beside him. He asked 3 questions: whether the 17-degree pencil angle was critical or approximate, whether a different pencil hardness would affect the result, and whether she had any data on inspectors other than herself attempting the method. She answered all 3. She told him the angle was critical. She told him the 4H hardness was the minimum reliable grade. She told him she had not yet had the opportunity to train anyone else in the method, as it had not yet been formally approved. Morrison looked at her for a moment. Then he looked at his colleague. Then he wrote something in his notebook and asked Grout whether there was a room they could use for a technical discussion. Edith was not invited to the discussion. She went back to the inspection bench and continued working. The Air Ministry issued an interim inspection supplement, not a full protocol revision, an interim supplement, on the 12th of October 1943. It described a surface continuity check for wing skin and fuselage panel camber seams and referenced the use of a hard-grade marking pencil as an auxiliary tool for identifying geometric departure from design specification. It did not name Edith Marsh. By the end of October, the pencil line check had been adopted informally at 2 additional aircraft factories, Vickers Armstrongs at Weybridge and the Hawker facility at Langley. Through the kind of lateral communication that happens between factory inspectors who talk to one another at industry liaison meetings, a woman named Patricia Holden at Weybridge later wrote in a memoir that she had been shown the technique by a colleague who had seen it demonstrated at Castle Bromwich, and that she had immediately understood it because she had been a technical draftswoman before the war and had spent years looking at lines for a living. By December 1943, the method had been formally incorporated into the inspection checklist for Hawker Typhoon production at Langley. In the first 2 months of its use there, it flagged 31 panels that had cleared standard inspection. Of those, independent analysis confirmed structural concerns in 26. In total, across 3 factories between October 1943 and the end of the war, the pencil line continuity check was credited in Air Ministry production records, with identifying and removing from service an estimated 214 compromised panels. The RAF's own post-war structural failure analysis estimated that the removal of those panels prevented between 40 and 60 in-service structural events that, at operational altitude and speed, carried a significant probability of aircraft loss. 18 aircraft were specifically identified, retrospectively, as having been cleared for service by standard inspection before the pencil line method was applied to their panel batch, and subsequently grounded after reinspection using the new technique. 18 aircraft, whose pilots never knew what had not happened to them. Group Captain Reginald Farrow, the Air Ministry's Deputy Director of Production Quality, visited Castle Bromwich in February 1944. Edith was not told the visit was happening. She was at her inspection bench when Grout appeared and told her there was someone who wanted to see the method demonstrated. She demonstrated it. Farrow watched, asked 2 questions, both technical, both good, and then stood for a moment looking at the inspection bench. "You developed this yourself?" he said. "Yes," she said, with no formal engineering training. She told him she had trained as a technical draftswoman. He nodded slowly in the way of a man filing information into a category it doesn't quite fit. He told her that the interim supplement would be made permanent in the next revision of the manufacturing inspection standard, which was due in the spring. He told her that her name would be noted in the internal correspondence as the originating source of the technique. He did not tell her what that notation would mean in practical terms, which was that it would appear in a file that would be read by perhaps 4 people and archived in 1947. "Is there anything else you've noticed that isn't on a form?" he asked. She told him yes, there were 2 other things. She had been waiting for someone to ask. He took out his notebook. Edith Marsh left Castle Bromwich in August 1945, when the factory converted back to civilian production and the inspection team was reduced. She went back to draftsmanship, working for the next 19 years at a Coventry engineering firm that made industrial compressor components. She was good at it. She was quietly respected. She never spoke about the war work to colleagues unless directly asked, and even then she was brief. The pencil line continuity check appeared in its final permanent form in the RAF's Manufacturing Inspection Standard Revision of April 1944. It remained in use, in various forms, in British aircraft production quality control into the mid-1950s. When the aerospace industry transitioned to coordinate measuring machines and laser surface scanners in the 1960s, the technique became obsolete, replaced by instruments that could, at last, measure what Edith had been measuring with a pencil. In 1971, a researcher at the Imperial War Museum working on a history of wartime factory production tracked down a copy of Edith's original 14-page report, the one she had rewritten in the required format after Grout told her the first version didn't count, in a folder of miscellaneous Castle Bromwich inspection correspondence. He noted in his own research file that it was a remarkably clear document, technically precise and entirely self-taught in its approach. He was unable to locate Edith herself. She had moved, and her name was common enough to be difficult to trace. She died in 1983 in Leamington Spa, the town where she had grown up learning to draw true lines at her father's kitchen table. The Air Ministry file that noted her name as the originating source of the pencil line inspection technique was declassified in 1992. A historian writing a paper on wartime women in technical roles found it in 2001. The paper was published in a journal with a circulation of approximately 800 readers. Edith would not have been surprised by any of this. She had spent her professional life understanding that the most important things are often the things that nobody thought to put on a form, and that the value of seeing something clearly has nothing whatsoever to do with whether anyone notices you seeing it,